Hi guys, and welcome back. So we're going to go ahead and jump straight to the problem. So we have a rational expression and inequality symbol all together. Rational expression, inequality symbol. We're going to call it rational inequality. So what are we going to do today? We're going to solve these bad boys. Okay, we're going to solve rational inequalities. How? There are different ways to solve them, but today we're going to focus our energy by solving them by using test intervals. So I'm really hoping that you watch the video on solving quadratic inequalities by using test intervals. The strategy to solve these inequalities by using test intervals are the same, okay? But of course, because the problem is not exactly the same, so something will change a little bit, okay? Cool. So we are not given the liberty to solve this however we like. We have to answer by using test intervals, and then as expected we are asked to write the answer or the solution set in interval notation. Okay, how do we solve a rational inequality by using test intervals? So it's a 4-step process. Let's take it one step at a time. Step number 1, fix it so you have 0 on one side. I don't care where the 0 lands, left or right. We just want 0 on one side and a single fraction on the other. Now someone said, oh, I know you as Taurus from back in the day, and you said that you hate fractions, so let's wipe them out. You know what? I still hate fractions. Oh, sorry, hate is such a strong word. I still dislike fractions, but when it comes to solving rational inequalities, I gotta suck it up and keep the fraction. Why? Because if I wipe it out, I'm gonna get a totally different answer. So to solve rational inequalities, our first step is to fix it so there's a 0 on one side and a single fraction on the other. So the fractions are here to stay, okay? So if we subtract 2 from both sides, that's gonna give us 3 over 2x minus 1 minus 2 is less than or equal to 0. Okay, so we have part of step 1 nailed. Step 1, fix it so there's 0 on one side and a single fraction on the other. Okay, we don't have a single fraction on the other, but we're gonna get to it. Let me go ahead, zoom in, and then I'll zoom out as needed. So we are asked to subtract these two things. So there's only one denominator, so whatever that one denominator I see, that's going to be the least common denominator. Okay, so in this case, the least common denominator is 2x minus 1. Let's go ahead and write those equivalent fractions. We're going to write 2 as a fraction, namely 2 over 1. And then with confidence, I'm going to ask myself, oh, what am I going to multiply that 1 by to make it look like the LCD? In this case, we're going to multiply top and bottom by 2x minus 1. You know what? Let me go ahead and rewrite it. I was going to squeeze it in, but I like myself like a lot. Okay, so I don't want to have a messy work. Okay, I'm supposed to use my notes to prepare for quiz or test, so the worst thing I can do to myself is squeeze it. Okay, so let's multiply top and bottom by the LCD just found. Okay, namely 2x minus 1, and then we'll bring down the rest of the problem. Okay, so now the question is, are the denominators the same? We got a 2x minus 1 here. 1 times 2x minus 1 is 2x minus 1. So we do have the same denominator. Now that the denominators are the same, let's go ahead and subtract the rational expressions. So to subtract the rational expressions that have the same denominator, we're going to subtract the numerators and then write the difference over the common denominator. So the first numerator is 3, and then we're going to subtract from it the second numerator, which is 2 times 2x minus 1, and we write that over the common denominator. Okay, we bring down the rest of the problem. That is less than or equal to 2. Let's take our time, clean up the numerator, and then we'll worry about step number 2. Okay, so for the numerator, when we distribute the negative 2, that will give us negative 4x plus 2, and that's still all over 2x minus 1. Okay, let's keep doing this. When we continue to simplify the numerator, when we put down the x's first, that will leave us with negative 4x. When we combine the constants, sum of 3 and 2 is 5, and that's all over 2x minus 1. Alright, so step number 1 complete. Step number 1, how do we solve a rational inequality? Step number 1, fix it so there's a 0 on one side and we have a single fraction on the other. Step number 2, find all zeros. So we have it in the notes, but let me go ahead and write it out. Find all zeros. Okay, step number 2, find all zeros. So this fraction has a top and bottom, okay? So we're going to have to find zeros on the top, zeros on the bottom. So when we are asked to find all zeros of a rational inequality, I want to know what are zeros of the numerator and what are the zeros of the denominator. So when I ask myself what are the zeros of the numerator, I'm pretty much asking myself what makes the numerator a zero, okay? So if we want to know what makes the numerator a zero, we're going to take the numerator and set that equal to 0, okay? So we have negative 4x plus 5, and let's equate that to 0 and then do what we got to do. When we subtract 5 from both sides, that will give us negative 4x equals negative 5. And after we divide both sides by 4, that will give us any equivalent form. That will give us x equals any equivalent form of 5/4. We can leave it as an improper fraction, we can write it as a mixed number, or we can write it as a decimal. I myself prefer the improper fractions, but students love the decimals, so I'm going to give the people what they want, okay? So we're going to write it as x equals 1.25. Remember, decimals are fine, just make sure you don't round them, okay? When we locate the 0 on the number line, I'm going to ask myself, is 1.25 part of the solution? Well, that question is dictated by the inequality symbol. If the inequality symbol has what I call the equal to part, then it is part of the solution. If the inequality symbol doesn't have that equal to part, then it's not part of the solution. This inequality symbol has the equal to part, so 1.25 is a part of the solution. So we can graph it, or how the books say, closed circle. Okay, so for the rational inequalities, okay, step 1, fix it so you have 0 on one side and a single fraction on the other. Step 2, find all zeros. Find zeros of the numerator, find zeros of the denominator. So if I want to find the zeros of the denominator, pretty much I'm asking myself, what makes the denominator equal to 0? Which kind of sounds like a trick question, because we had said, wait, the denominator can't equal 0. So let me put a little love note. But denominator can't equal 0. Let me go ahead and use my made up notation. Okay, I don't have time to write the word can't, so we're just gonna say it's not equal to. Okay, so yeah, let's go ahead and find zeros of the numerator and then remind ourselves that the denominator can never equal 0. So no matter what this inequality states, for the zeros of the denominators, we have to use open circles. Okay, so we have 2x minus 1, set that equal to 0. So we want to find zeros of the numerator, zeros of the denominator. Alright, let's do this. When we add 1 to both sides, that will give us 2x equals 1. And after we divide both sides by 2, that will give us x equals 1/2. 1/2 is a pretty nice number, but if I went with a decimal here, I'm going to keep my notation consistent. But if you're like, no, I love the fraction, then keep it. Okay? So then I'm going to ask myself, is 0.5 part of the solution? And the answer is no. Okay, the denominator can never equal 0. So I'm going to say must use an open circle. Okay, why? Because the denominator can never equal 0. Okay, so let's go ahead, use these zeros to split the number line into test intervals. I'm going to write down the number line here. I'm out of space, so okay, so I'm going to write it here and then copy it over. So the zeros are 1.25 and 0.5. This is a number line, so the smaller number should appear first and the larger number should appear thereafter. So we have 0.5 and 1.25. 1.25 is part of the solution, so we can graph it. So we'll do a closed circle. 0.5 has to be excluded, so we're going to do an open circle. Okay, so I'm going to go ahead, take a pause, and then just write this over. Alright, so I went ahead and took the number line and copied it over. Okay, so remember, whenever we have to start a new line, please be nice to the grader and let them know where to look at next. So we have 2 zeros, and those 2 zeros, it's going to split the number line into 3 test intervals. Okay, step number 1, how do we solve a quadratic inequality? Oh, sorry, wrong problem. Step number 1, how do we solve a rational inequality? First, we got to put 0 on one side. put 0 on one side, have a single fraction on the other, then find all zeros, then use those zeros to split the number line into test intervals. Okay, so it would be really nice if you numbered those intervals 1, 2, 3. So the first test interval is pretty much all the numbers under 0.5. Test interval number 2 is going to be the numbers from 0.5 to 1.25, and then test interval number 3 is going to be the numbers that are bigger than 1.25. So please number them, and then as you test them out, please go ahead and number them again, so that way I know, okay, you're going to test out 1, then 2, then 3. We're going to go ahead and write our test value. So again, a test value is a value that you're going to test out. You can test out any value of your liking as long as it's in that interval. Is 0 in here? It sure is. So let's go ahead and test out 0. Okay, now where should you test it? So you could test it wherever you want. You could do the original inequality, you can do the revised inequality. It's a personal choice. For me, I usually plug it into the one, I usually use the one that's being compared to 0, but in all honesty, let me go ahead and zoom out. I think the original inequality is a lot easier to digest than the revised one. Okay, so we're going to plug it into the original one. So let me go ahead and highlight it because I speak to myself. Okay, so we have 3 over 2x minus 1 is less than or equal to 2, and let's see if our test value is a solution. Again, we cannot read each other's minds, so I'm not expecting for you to also test out 0. This is why it's imperative, I think that's the word I'm trying to find. This is why it's important that you tell me which test interval you're testing out. Alright, so we have x equals 0, so we have 3 over 2 times x. In this case, it's 0 minus 1. I need to know, is that really less than or equal to 2? Product of 2 and 0 is 0, and the quotient of 3 and negative 1 is negative 3. So the question that I'm going to ask myself is this: is negative 3 less than or equal to 2? And the answer is yes. So check it out. Because our test value is our solution, that means that every other real number is in this interval is also a solution. I'm not sure if I made sense. Okay, so our test value checked out. Our test value is a solution. That means that all the other numbers in this interval is also going to be a solution. So let's go ahead and graph them. So someone said, do we really have to graph our answer? We don't. We just have to solve it. But I said it before, and I'm going to say it every single time. The worst thing you can do to yourself is do the algebra, but then forget to answer the question. So I'm hoping that if you graph your answer along the way, you'll be like, oh man, I gotta answer the problem. Okay, so 1 interval down, 2 more to go. Okay, so let's go ahead, test out the second interval. You can pick any number of your liking. You could pick a decimal for all I care, but I like to stick with integers. So the integers, if I stick with an integer, it's just 1. Okay, so maybe this will be the problem where we all read each other's minds. And I'm going to go ahead, test it into the same one. You don't have to rewrite it. I just ask that you write it at least once. Okay, and then I'll know that you're going to keep plugging it into the same one. Okay, so we have 3 over 2 times our x, which is 1 minus 1. And I need to know, is that really less than or equal to 2? Okay, so that will leave us with 3 over 2 times 1 is 2. We could subtract 1 from it, but I'm trying to minimize the number of steps that I overlook. Okay, I can do things in my head at times, but when I skip steps, I tend to make mistakes. Difference of 2 and 1 is 1, and quotient of 3 and 1 is 3. So the question that I'm going to ask myself is this: is 3 less than or equal to 2? And I'm like, oh man, is 3 smaller than 2? It's a lie. It's not. Okay, so check it out. Because 1 is not a solution, that means that none of the other numbers in that interval is also going to be a solution. So let's cross it out for dramatic effect. 2 intervals tested, 1 more to go. So test interval number 3, we want to test out any number that's bigger than 1.25. So I'm going to stick with 2. If you want to pick 43, then go for it. Okay, why 43? I don't know. I just say numbers at random. Okay, so let's test out the third and final interval. So again, tell me what interval number you're testing. Highlight make a note of what test value you're picking and then plug it in. Okay, so I'm going to plug it into the same one. Okay, so we have 3 over 2 times x minus 1, and I need to know, is that less than or equal to 2? So let's do this. So we have 3 over product of 2 in itself is 4. Difference of 4 and 1 is 3. Quotient of 3 in itself is 1. I don't know why. I feel like I made a mistake. Did I make a mistake? No? Okay. Well, send me an email if I did. Okay. So the question that I want to ask myself is this. Is 1 less than or equal to 1? And the answer is, yeah, it is. Okay. 1, let me say it like this. The left side could be less than the right side, or the left side could equal the right side. So in this case, it's the second one. Okay, so 1 is less than or equal to 1. It just looks weird. Okay, so our test value is our solution. Since our test value is a solution, that means that every other real number in that interval is also a solution. So let's go ahead and graph it. Okay, so let's go ahead write down the answer. So because I have to move my paper around a lot, I'm going to give you the answer verbally. So what is the solution set? I'm going to say it in like English, and then I'll say it in interval notation. So the solution set is given by the numbers that are less than 0.5, or the numbers that are at least 1.25. So the numbers that are under 0.5 and the numbers that are more than 1.25, where 1.25 is included. In interval notation, it's going to be the interval from negative infinity to 0.5, where 0.5 is excluded. And then we're going to say union, because we're way too cool to say or. Union interval from 1.25 to infinity, where 1.25 is included. You got that? Cool. So let me sign out. Just kidding. All right. So let's go ahead and write our answer. I can't project the graph, so you're just going to have to trust me. So the solution set is given by the interval from negative infinity to 0.5, where 0.5 is excluded. Or, I say or, but we use the union symbol. Okay, union, interval from 1.25 to positive infinity. The infinities always get parentheses, and in this case 1.25 is included. Okay, so remember, we cannot read each other's minds. If you choose to keep the fractions, that's fine. I think the book keeps the fractions, but I don't care either way. Okay, guys, that's my time. Thanks.